visible to the garbage collector. So instead of having a million references, you just have a single blob which has like 1 gigabyte, and all the objects are in there. But because it's a single reference, it's not affected by garbage collection. And then there are various modes, so you can store your data in the binary array, or sorry, byte array on heap, or you can store your data in the direct buffers outside of heap, which is still in memory. Then you can use some sort of exotic store like sum is unsafe. You can use memory map files. You can you can also overflow them into some sort of append-only store.
Yeah, the point is it's fully under your control, which is a nice.
Basically, if you have a byte buffer, and if you we have some sort of abstraction of a byte buffer, and if you implement that, you can provide storage. So right now we are working, for example, on the store which will implement raw disk. So you will get raw access to the raw partition with no file system overhead.
So literally, these two questions.
Yes.
I came a little late, but reading this here, when you look at a relational database, optimization of the SQL database is based on algebra, relational algebra. Okay? So are you saying that so if you use the relational database, the optimizer is there based on the algebra. So why do I want to move the optimization into?
Yeah,
I'm just reading this.
No, that's a good question. This was a user of the MapDB project that actually took something in a relational database and converted it to an object form in MapDB.
But you're not replacing the optimizer.
No.
So why do I want to move into?
No. But he was able to do things faster.
Why would anybody? If you have an optimizer in the relational database, that's a good optimizer. An algebra, which is really algebra. You know, joins, natural joins, etc. Are you doing the same thing? No.
Basically, MapDB is not database, so I tend to say it's not a database. If people ask me if it's the question was if MapDB has optimizer and if you are replacing optimizer. And basically, I tend to say that MapDB is not database, it's a database engine, which is basically a low component on top of which you build a database. So basically, we don't have optimizer because it's on a different abstraction layer than the
abstraction than the optimizer.
Yes, that's right. So basically, if you will be building database, you will use MapDB on the bottom, and then you will put some sort of query optimizers and stuff like that on the top of it. But the thing is, MapDB is very optimized to be very Java friendly and very user friendly, and so many people are actually using it as database directly because they get many benefits of, for example, some sort of object relation mapping frameworks are providing instance caching, so your data objects are stored in this serialized form. But MapDB is database engine, but it actually provides these features as well. So I would say that basically MapDB is some sort of database engine optimized for Java usage. You get plenty of benefits from when using full Hibernate stack with SQL database, but you can actually just use single component for that. And because you are using single component, for example, there are actually only 3 abstraction layers: the data model, the memory model, and the raw byte buffers. Because you are using very little abstraction layers with MapDB, there is not that many data copying and so on, and it's much faster than passing your data through many abstraction layers.
So we have time for maybe one more question. Any others? Yes.
So when you created that DB object, that created an underlying file, correct?
Yes.
If you're creating a file database.
Could that DB object then be used for a map, a tree, a set, or is it?
That's right.
You could have
12,
3 different data types.
You could have 12 different structures.
Basically, DB object is factory for other objects. Yeah. So you use the DB object load or open existing data types. There are about 50 methods, and you get atomic longs, atomic variables, and atomic strings, and queues, and sets, and so on.
And probably the size of your DB, the size of your D3 leaf is also configurable?
Yes. You can also configure various options like custom serializers. You can configure the node size, some sort of overflow. You can have a inline or outline values, and so on. And it's basically B-Link plus 3, which is used in Postgres as well, so it's well understandable structure.
Yes, one last question.
What is the typical use case? Can you give us some examples?
I'm kind of worried there is no typical use case. Basically,
No, I mean, even in development environment.
it was kind of developed as hobby project, and the question was, what's the typical use case? And the thing is, it just kind of happened. Until 2 years ago, it was just hobby project, and then about a year ago, I quit and started working full time. And basically, it just sort of happened. I saw good design, and I kept extending it. And the ultimate use case is that it should be some sort of extension of the concurrent utilities in Java. So some sort of de facto standard database engine for Java. So basically my kind of vision is that if you will have some sort of big data or some sort of data processing, MapDB will be first thing you kind of try before you start using specialized solutions. Basically it tries to be universal database engine. So
yeah, and I might add one thing, which is a very typical use case we see is that people are running out of heap memory or fighting garbage collection. That's an easy one. That's a very easy use case. But we're using it inside of our technology. You'll hear more about that throughout the show as well. Yes?
I have a question. So do you support
sorry, there was a question.
For example, suggestion, are they available in the web?
They are not available on the web, but basically if you go on the mapdb.org or you just search MapDB on the Google, there are like 20 examples of how to use MapDB on the GitHub. So those examples are kind of derived from the generic examples in the MapDB.
Very similar.
Streams API. I'm planning to support Streams API.
We are already supporting Streams API in front of the conversion, in the sense of conversion. So you can actually JDK 8 is backward compatible with map implementation, but we have some sort of plans for the streams as well.
All right, well, I want to thank you all for coming. If you have other questions, we'll be around afterwards. Thank you.